Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we are from Group 6, EMM4713 Operation Research. We present our task week 5, Simplex method. So in this task, we will explain about the example given from the slide. So this is my group member, consists of me, Muhammad Zakwan, Muhammad Aiman, and Muhammad Ilham. So let's proceed to the question or the problem. So there is a furniture company, the Dakota. The company manufacture three types of product, which is desks, tables, and chairs. And then the requirement is lumber and two type of skill labor, which is furnishing and carpentry. And then the table is given from the question, and the available of the lumber and also finishing hours and carpentry hours are given, which is 48, 20, and 8. And then the selling price of the product also given in the question, in the description, which is $60 for desk, $30 for table, and also $20 for chair. And then there is also the demand for it is stated that the demand for desks and chairs is unlimited, but uh, at most 5 tables can be sold in a month. So Dakota want to maximize their total revenue. Uh, so from the table is the requirement for the resource such as lumber, finishing hour, and carpentry for each product. So from the question given, we can construct. Firstly, we define the decision variable, which is we assume x1 is desk produce, x2 is table produce, and x3 is chest produce. And then for the total revenue equation, total revenue is the total selling of the company. So the Dakota want to define their maximum revenue. So the linear programming equation is z equal to 60x1 plus 30x2 plus 20x3, which is the selling price of each product. And then from the question also, we can construct the equation, which is lumber constraint, because we have 48 lumber available, and also same for the furniture and carpentry, which is 20 and 8. And then there is another question, which is x2 less than or equal 5, because at the end of the question it stated that at most 5 x2 tables were sold in a month. So there is the equation we construct from the question given. And then the next step is we want to convert LP to standard form, linear programming equation to standard form. So firstly, uh, we need to derive the objective function, which is the objective function of this equation is z minus 60x1 minus 30x2 minus 20x3 equal to 0. And then the canonical form will construct, which is we added s for each equation, and we change the symbol to equal. So we have 5 row from row 0 and row 4. And then next, I will pass the presentation to my colleague, Muhammad Aiman.
Okay, thank you, Zakwan. Okay, so I continue. So we are taking the canonical form 0 to do a feasible method for F0. So next. So we are taking the row 0 at negative 60 at x1 because we are taking the most negative value for which we select for the entering variable, which is the x1. And next, we're doing the ratio test so we can find the pivot. So from this ratio test, we're taking the row 3 because there is a smallest value in ratio test. So we're taking the smallest value. And next, for the x1, for the row 3, we need to change the coefficient of 1, and we need to change the coefficient of 0 in all other rows except for the row 3. So next. So to make x1 a basic variable in row 3, we are for performing the ERO. So for the ERO first, we create a coefficient of 1 for x1 in row 3 by multiplying row 3 by half. So the resulting row is x1 plus 0.75 x2 plus 0.25 s3 plus 0.5 s3 equal to 4, as you can see at row 3. So next, for the ERO2, we need to create a zero coefficient for x1 in row 0. So we replace the row 0 with 60 times row 3 plus row 0. So we can eliminate the negative 60. So we can get the value of z plus 15x2 minus 5x3 plus 30x3 equal to 240, as you can see in row 0. So next, we're doing the RO3 to create a zero coefficient for xy in row 1. So we replace the row 1 with a negative 8 row times with row 3 plus row 1. So we get the value of negative x3 plus s1 plus, minus 4s3 is equal to 16. So the last one, we create the row 4, which is to create a zero coefficient for x1 in row 2. So we replace the row 2 with negative 4, multiply with row 3 plus row 2. So we get the answer of negative x2 plus 0.5 x3 plus s2 minus 2s3 is equal to 4. So rearrange into this canonical form, which is we describe this finalized canonical form as canonical form 1. So for next part, I will pass to Idham. Thank you.
Okay, after we're done with the canonical form 1, we will move on to the next one. And since there is still a negative value in row 0, so we'll still do another canonical form. And if we look at the row 0, x3 have the most negative value, which is negative 5. So we will make x3 as the entering variable. And to determine which row will be the pivot, we will do the ratio test, and the second row have the smallest ratio. So row number 2 will be the pivot. And so with that, we will make x3, we will make the coefficient of x3 in row 2 as 1, and coefficient of 0 for other rows. So first, we'll create a coefficient of 1 for x3 in row 2 prime while multiplying row 2 prime by 2. And then we'll create a zero coefficient for x3 in row 0 prime by replacing row 0 with 5 times row 2 prime row 2 double prime plus row 0 prime. And third one, we'll create zero coefficient for x3 in row 1 by replacing row 1 with row 2 double prime plus row 1 prime. And lastly, we will create coefficient of x3 in row 3 by replacing the row with row 2 double prime times 1/4 and plus row 3 prime. And then we will get the canonical form as shown below, where there is no negative coefficient left on the row 0. So this is said to be the optimal solution where there is no negative coefficient. And with that, we found our answers to x1, x2, and x3. And to maximize the value of z, we we need x1 to be 2, x2 to be 0, and x3 to be 8 to gain the maximum revenue of $280. That's all from us. Thank you.